Okay, for what this is video part 4 of official book AP Calculus, chapter 2, continuity. For what value of a is the function f of x given by ax plus 5 when x is less than 4, x squared minus x is x given when x greater or equal 4, continuous at a point x equal 4. Okay, let's go to more space maybe. Ax plus 5, x squared minus x. It's f of x equal ax plus 5 when x less than 4, x squared minus x when x greater or equal 4. And it is continuous, given continuous at x equal 4, and we need to find what is the value of a. Let me just check. Ax plus 5, x squared minus x. That's correct. Okay, so let's start. What's the meaning of it is continuous at x equal 4? This means we have for sure limit of f of x as x tends to 4 minus equal to the limit of f of x as x tends to 4 plus, and all of them are equal, both of them are equal to f of 4. What is f of 4 equals to first? Let's go and see what is f of 4 equals to. F of 4 equals to, when x equal 4, we substitute it in the second part of this function. So it will be 16 minus 4, and that is 12. Okay, we choose either this one or this one to make it equal to 12. But this one, as x tends to 4 plus, we are going to see the same result, which is in the second part. So let's go for the limit of f of x as x tends to 4 minus. Limit as x tends to 4 minus, because we have a here, right, of ax plus 5. X approaches 4 minus means when x less than 4. This means equals, right? We substitute instead of x its value, which is 4, for a plus 5. And since we have continuity, then this limit should be equal to f of 4, which we found it as 12. So in this case, for a plus 5 is equal to 12, and we solve for a. For a equal 12 minus 5, which is 7, then a should be equal to 7 divided by 4. Here is the solution. A should be equal to 7 divided by 4. Okay? So the solution of this problem is a equal 7 divided by 4. You can try it by yourself. Problem 4. What does the function f of x equal so have? Where does it have an essential discontinuity, a removable discontinuity? First, we have to check where it has essential discontinuity, where the function has removable discontinuity. Okay, let's see. It's easy. Let's factorize this problem, and we can find it really fast. Let's factorize it first. 2x squared, it's 2x times x by guess and check. The minus is plus times minus, or maybe minus times plus. We have to guess. And this is 3 times 5. Let's see if this is correct. Minus 5 times 2, it's minus 10. Plus 3 times 5 is plus 3. So minus 10x plus 3x gives me minus 7x, which is correct. The other one, I guess one of the factors should be x minus 5 as above. So the other factor should be x plus 4, because plus 4 times minus 5 gives me minus 20, and x times x is x squared. The extremes are minus 5x. The means are plus 4x. What left is minus x, which is the middle one. That's 100% true. Okay, we can simplify for x minus 5, right? First, what left is x plus 4 in the denominator. And if we go and find it's 2x plus 3 over x plus 4, right? 2x plus 3 f of x. Now, after simplifying, it's 2x plus 3 over x plus 4. If we find the limit of this f of x when x approaches 4, negative 4 minus. X approaches negative 4 minus. Because when x plus 4 equals 0, this gives me that x equal minus 4. And we shouldn't have it equal 0 because it is in the denominator. So we have vertical asymptote here. We should have vertical asymptote. Let's see if this is true. That is equal. Limit, we substitute negative 4. Up will be negative 8 plus 3 over negative 4 minus positive 4. Okay? This will give me negative 5 over negative 4 minus, it's negative 4 minus plus 4. That will gives me what? We should be careful here. Okay, negative 4 minus means what? Negative 4 minus means it's a bit. This is negative 4. And this is a negative 4 minus, could be, right? Because it's negative 4 minus equal negative 4, negative epsilon. So it's a bit before negative 4. So here, negative 4, positive 4 is 0. Since the absolute value of negative 4 minus is more than the positive 4, that will be negative 0 minus, and the answer will be positive infinity. And if we find the limit of 2x plus 3 over x plus 4 as x approaches negative 4 plus, we get what? We got that negative 8 positive 3, negative 4 and a positive epsilon to it, added to it positive epsilon. That will gives me negative 8 and negative 5, right, over 0, but it will be 0 plus because the 4 is more than the negative 4 plus. That will gives me minus infinity. In case we have positive infinity or minus infinity, we have a vertical asymptote, and we are going to see that later on. But this is considered as essential, right? Essential discontinuity. One more thing. This is part A. Part A is essential discontinuity. Part B is what? If you remember, we used to have x minus 5 in the numerator and denominator, and we did cancel it. This means if we substitute 5 in f of x here, if we substitute 5, what is f of 5? F of 5 equal 2 times 5 plus 3 over 5 plus 4. That will be 13 over 9. So the 0.5, 13 over 9, in the original function, it will act like a whole. This means in the original function, we consider this point as a removable discontinuity. This is part B. All right, that's great. So part A is essential. We have essential because we have answer as infinity. We have vertical asymptote. We are going to learn that later. And part B, it's removable discontinuity because we removed the 0.5 from the original function. And that's it for this video, and see you next video.